Hello, I'm Zekun Wu, an AI researcher at Holistic AI and a PhD student at University College London. Today, I will highlight our latest AI ethics research focusing on stereotypes within large language models and our novel detection strategies. First, what is a stereotype? Stereotypes are generalized views about what a particular group is expected to be or actually does, or the roles that should be performed by specific groups. They exist since we are as human desire to create cognitive shortcuts to help us categorize our experience and help us to process things faster. For example, common stereotypes include all good leaders are male, which could negatively impact female, that female are too emotional, or older people are more stubborn. These negative stereotypes can lead to bias and discriminations, therefore impact opportunities available for certain groups. Although stereotypes exist in society, they can also transfer into technologies such as large language models. This is because large language models are trained on vast amounts of unfiltered data, such as book and Wikipedia corpora, and large internet corpora like Common Crawl. These training data often exhibit systematic biases which are reflected in the outputs of large language models, perpetuating and amplifying potential negative stereotypes. Well, this is an important phenomenon to investigate. Most existing studies focus on either bias benchmarking in large language models or text-based stereotype detection and overlook the interaction between them. Our method starts with building the multi-grain stereotype dataset, which contains over 50,000 examples of stereotypical tests about gender, race, professions, and religions. We then train a multi-class classifier on this dataset to identify stereotypes in English language texts. Our findings are threefold. First, our multi-class training outperformed traditional 1vs0 binary approach in detecting stereotypes. Second, we confirmed through various explainability tools that our classifier effectively learn and use the right text feature for identifying stereotype. Lastly, by applying our model to the GPT series, we've observed a measurable decrease in bias over time. Here is our benchmark results. The lowest score is the best. As you can see, GPT-2 gets the highest score, GPT-3.5 gets the lowest score on race and religions, and GPT-4 gets the lowest score on profession and gender. On average, GPT-4 gets the lowest score. Here is our results of explainability validations. For the first one, the sentence, "I have mother, she is always protective of her kids," have been classified as gender stereotype. And we can see the words protective, she, and mother contribute to the prediction most. And we also have many kinds of examples that show our model intuitively learn the pattern that align with our human common sense reasoning. We employ expandable AI techniques and consider classifier with small parameter size to make the audit process transparent and energy efficient, thereby meeting ethical and sustainable standards while improve predictive performance. In the end, our framework is notable for its scalability and minimal carbon footprint, crucial in which are stepping into an age where large language model content will dominate the whole internet. This scalability is vital for accessing the biases and stereotypes in large-scale datasets and models, ensuring integrity and unbiased digital media in a world heavily influenced by social media and generative AI.